Now that I have been doing a lot of linear algebra, I wanted to get me more books with linear algebra from a machine learning perspective. I found this great book by Aggarwal, and I've taken a good look at it. I've read parts of it, very brief, literally a few pages. Not sure if it's the type of book that I would use the way that I usually use books, where I read them cover to cover and attempt most problems. I would have to probably do something like with TensorFlow examples, maybe a specific data set, something like that. But yeah, let me go through the table of contents. So it's got a very basic introduction to linear algebra, but it really is just a linear algebra book. Goes into eigenvectors, your basics of linear algebra, although LU decomposition, for example, is something that you would do later in a linear algebra course. So this does not look to me like a first book in linear algebra for anyone. Especially it wouldn't be for me. So then the machine learning view, and then some advanced optimization. So the Newton method, I see the Newton method right there. So it's got a lot of applications, The book is very well written and it's got a lot of stuff. This is really the priceless chapter of the book, SVD, which happens to be very useful in data science. And I really wanted to have a book that had a ton of information about it. And this book is it. So it's got a whole bunch of it. Of course, more about matrix factorization. And then, of course, similarity transformations, generalizing it because SVD is a type of similarity transformation. And then linear algebra of graphs, and then computational graphs. So this book is rich, very rich, very well written. He also has authored several other books which I do not have. There is the man himself. Thank you, sir, for making such a wonderful book. And so, yeah, not sure if it's the type of book that I would do like I've done my other books, because even though it reads well, it is not at the polished college level textbook tier like Anton. Yeah, so I would have to give it a field test with some examples, but by the time I get around to this book, if I ever do, I would have already run through all of Anton, and so it won't be a problem. I could easily just skim through to the parts that are new to me and look at a few proofs and just revisit material that I've already read and really kind of do an end run, a fast end run to the parts that specifically talk about the applications of machine learning, and then work on those with something like a bunch of TensorFlow examples in Python. That's what I'll probably end up doing if and when I get around to this book. But yeah, it's got a ton of content. It is fairly affordable. I bought it brand new from Amazon. I forget how much I paid, but it wasn't a lot because I never pay a lot for a book. Yeah, the discrete Fourier transform. Yeah, but it's got a whole chapter on SVD, and that is really great. Yeah, really great. So a lot about optimization. Again, since I have not read the book, I cannot really give you a blow-by-blow of every single section of where I got stuck or where I didn't. But from all that I can see, it looks like it's really well written. It's got some problems. It doesn't have answers. I'm pretty sure of that, because that's one of the first things that I check when I look at a book. But yeah, one more book for my linear algebra library. This is the money chapter in here. Yeah. Definitely, with examples. Yeah. It would be great if it had a few answers, but it takes a lot to build up a book like Anton, and that's okay. There's already Anton out there and other books, like the books by the MIT man himself. Yeah, there you are. Yeah, so it does not have answers. Just confirming, but it's got a really good list of references, and it references his other books. Yeah, Gilbert Strang. Gilbert Strang is the person that I meant to say, the MIT person.